This conference will now be recorded.
Can you hear me now?
Yes, we can hear you.
Yes, sir.
Okay. I'm sorry. Okay. Yeah, I think now connected to the other laptop. Now it should be clear. Let me just change the name. Joined as admin. So let's start off with the session. So we were discussing about the demo session. So today we are starting off with the demo session for the front-end domain courses. As we know, front-end domain consists of multiple courses, like in VLSI design flow. Just give me 1 or 2 minutes. I need to catch my flow in the training, so things will be fine. So as you are aware, the VLSI design flow consists of multiple steps, starting from the requirements till we do post silicon validation. Then finally it goes into packaging. There are a lot of steps in between. So these steps can be majorly called as design architecture, the RTL coding, then functional verification. You can even call something called as RTL integration. Then we have functional verification. I'm just filling the dots. What when I say dots, what exactly is that? Okay. Those attending online, can you hear me?
Yes, we can hear you.
Okay. So okay. So once the functional verification is done, then we have synthesis. Then we have the PNR flow, the placement and route flow. Then we have static timing analysis. In between, somewhere here, the RTL DFT flow will come in. DFT at RTL level, DFT at British level. Then we have the IR drop analysis. Then we have physical verification. Please be mute those.
ಕ್ಲಾಸ್ ಇದೆ ಒಂದು ಅರ್ಧ ಗಂಟೆ ಮುಗಿಸ್ಕೊಂಬತ್ತೀನಿ.
So you see, the number of steps are from 6 to 19, that is around 14 steps. I mean, you could even divide them into multiple sub aspects. Let's say after functional verification, I can even introduce something called as gate level simulations. Like that, if I start dividing, there could be another five, 6 steps that can come. Let's say after physical verification, we may go for fabrication. Majorly, this is what I would call it as. I mean, depending upon whom you ask, they may divide it into 16 steps. Someone may divide it into 10 steps, because I can place a lot of these things into just these 2 steps into RTL design. Instead of calling it RTL design and RTL integration separate, I can call it as RTL design. Now, as a fresher, if I tell you that which course you want to take, most of your freshers, you will be confused, right? This kind of confusion won't be there in software. If you go to software, there are only 2 job roles. One is design, one is testing. And 2 job roles are there. Either you choose whether you want to get into design role or whether you want to get into the testing role. So in testing, there are again 2 domains will be there: automation and manual. That is also not a big of not much confusion. Whereas when it comes to VLSI, it does become confusing, because you have to choose from lot of domains where each domain has a job role. Like if you ask a person who is working in, let's say I worked in functional verification. Okay, just about myself, my name is Srinivas. I passed out in 2005 dual degree. Then I have been working till 2019. I worked, and after that I quit my job, and now I'm full time into trading. So just about myself, for 14 plus years I have worked only into functional verification. I never did this domain. I didn't do any of this domain. I mean, I only did this. Like this, there could be a person who has done only DFT throughout his career. Probably even the time he retires from the job, he wouldn't have done anything else. Like that, there are some domains where you only get into the domain and you don't even have to look at other domains. So hence, choosing a right domain is important for you. Okay. At times, of course, there is a flexibility to move from one domain to other domain. But the problem is, once you have done functional verification for 5 years, moving to DFT won't be so easy. The reason is, again, you have to gain so much expertise in DFT to perform on par with a 5 years experience person, right? Just by doing a training course, you won't gain that expertise. So hence, choosing the right course is important for you. That is where we, instead of telling people that so many courses are there, I mean, we offer course in majority of them. We offer course in RTL coding, integration, functional verification, DFT, synthesis, gate level simulation, PMR flow, STA, IR drop analysis. So major aspects of this, we do offer the courses. But I can't confuse a student by telling there are 10 courses, which course you want to choose. Rather, what we do is we divide these courses into 2 categories. One is called as Frontend, one is called as Backend. Then we tell to the student that what to expect in front-end domain, what is the job role will be, and what do you expect in a back-end domain job role. Then initially, based on that information, you can make a decision, and after that, up to 2 months, you have an option to switch from front-end to back-end, back-end to front-end. Let's say you have selected a course in functional verification. It involves a lot of programming. Like in software, people use C, C++, and sometimes they use Java, some advanced languages, right? Like if you ask C and C++, which is more advanced? C++. Again, C++ and Java, which is more advanced? Java. There is a level of complexity, right? C, C++, and Java. Similarly, in VLSI also, there are languages like Verilog, System Verilog, and UVM. So someone may not like the programming much, and based on some senior suggestion, some friend suggestion, they have selected functional verification. There is always a flexibility where you move into some backend domain afterwards. Within 2 months, you can move anytime. Now, what we will do is let us talk briefly about what is this domains are about, so that you can make a right decision. My idea of demo session would be not to teach everything about functional verification, not to teach everything about DFT. It is to rather tell you what to expect in a front-end domain, what kind of skill set you require, and what to expect in backend. Of course, there is a demo session for backend training tomorrow. That time also, if you wish to attend, you get a better idea there also. So, to understand this domain flow, let us take one simple example. We can take an example of a simple thing like what can we take? Any design you can think of, a simple designs. Like mobile is a very complex thing. Okay, let's take mobile only. For example, mobile phone SoC, mobile phone chip. So when you go and purchase a mobile, what do you get? What do you purchase? Do you buy a chip? Do you buy a finally packaged product? So finally the packaged product. So what you are purchasing is the product which has packaged. So what goes into the am I audible now?
Yes, sir. Now you are audible.
Yeah,
Yes, sir,
okay.
you are audible.
Thank you. Okay. Okay. So as I said, when you purchase a mobile phone, what do you purchase? The packaged product. So the packaged product doesn't happen automatically. It has to go through the mobile phone that you are using has gone through all these stages. Typically, this process takes almost 2 years time, 2 to 3 years time in case of mobile phones. By the time, let's say you're purchasing a new mobile phone in 2023, that mobile phone manufacturing process, the requirements and architecture, everything has started almost in 2020-21 time frame. That is where it is available in your hands in 2023. So now, instead of going backwards, let's start from the beginning. What happens? So what happened? A company, let's say, who manufactures a mobile phone? Companies like Qualcomm. I mean, Qualcomm provides the chips. Qualcomm, of course, don't have their own mobile phones. What do they Qualcomm do? Tell me. I'm just taking Qualcomm one example. There is MediaTek, another company which manufactures mobile phone chips, right? So what does Qualcomm does? Qualcomm manufactures chips with a platform called as Snapdragon. You might have heard something called as Snapdragon. Where do you come across the term Snapdragon? When you open the mobile phone sheet, the data sheet, where they will give you one-page summary. What is that mobile phone consists of? They will say this kind of processor, Snapdragon 885. Then they will say USB 3.2 speed. Then they will say this kind of display. So one of the very important thing, that is the processor, and that whole platform is called as Snapdragon. Now similarly, MediaTek has a different name. Nvidia will have a different name. Okay, so Tegra, different names will be there. I won't go into that and confuse you too much. For now, just understand that whole SoC architecture. I mean, the components that goes into the SoC. SoC stands for what? System on chip. On the one chip. Chip means what? One silicon wafer. On that silicon wafer, entire system is present. What is meant by a system? Processor, graphics processing unit, display subsystem, the peripherals, memories, everything put together, we are calling as a system. Like, what is an example of a system in real life? Education system. Let's say you go to a college, there is a principal, there are lecturers, there are students, then there are supporting staff. Everything put together you call as a system, right? They become a system. Principal is not a system. Teacher is not a system. Student is not a system. Putting together various elements, what you get is a system. Same way in SoC also, you have the processor, you have the graphics processing unit, you have the display subsystem, you have multimedia subsystem, you have camera subsystem. All of them are connected to each other. That process is called as system, and since it is sitting on one chip, it is called as system on chip. S stands for what? System. C stands for what? Chip. System. What does system consist of? Various components that supports my mobile phone operation. For mobile phone to work, what all things do we need? We need the processor. Again, the same list what I repeated earlier, right? So again, this idea of this whole thing is not to confuse you. It's just to give you an outline of what happens in the manufacturing of a chip. Now, once the Qualcomm, so I will come back to this flow in a minute. I'll come back to this flow in a minute. Once the Qualcomm has manufactured a chip, what Qualcomm will do? Qualcomm will sell it to, let's say, LG. Then there are some companies, right, who take the chips and release their product. Which other companies are there? Samsung may or may not purchase from Qualcomm. Samsung may have their own platform. Samsung also has their own chip platform. I mean, mobile. They also make their own hardware, their own chips. Okay. Who else? Which other companies are there? When you purchase, go to mobile shop. What all things you see? Oppo, OnePlus, Redmi, right? Right. All these things. What do they do? Redmi don't have their own hardware manufacturing thing. What they do? They go to Qualcomm. They make a contract that we are going to purchase 1 million chips from you. And Redmi may develop their own embedded system. I mean, the operating system by using the what operating system you get in Redmi generally? The Android, right? Okay. So in that, I mean, so basically, what these companies will do, further they package, they the mobile phone manufacturers, what do? Is they buy hardware from Qualcomm kind of companies and either internally develop the software. I mean, develop the software and other applications. For applications, develop OS. I mean, maybe they customize their OS. Like Android is coming from Google, they will customize it and they will develop their own applications. They will integrate and sell it. So finally, what you buy is not just a hardware; it's a hardware with an operating system and applications. So when you say mobile phone, it is not just the hardware plus operating system plus the applications. So it is what these companies does. Let's say when you buy a Redmi mobile phone, when you buy Samsung mobile phone. So this is all what is there. This part of it, I mean, again, this whole domain can be divided into two parts. The people who develop the hardware, the people who develop the firmware, the something that is between hardware and the drivers. I would even call it as drivers or firmware plus OS, and the people who develop the operating system and the people who develop applications. Like what is an example of application? Like you go to Play Store, just install anything, IRCTC app, anything, right? For that matter, all of them are applications. So there are people who develop the hardware, there are people who develop drivers, then there are people who develop operating systems, then there are people who develop applications. So what is the order in which they work on each other? At the very bottom layer is the hardware. On hardware, what is present? The drivers. Drivers are interfacing at top with operating system. On top of operating system, you install application, apps, what you call as apps. This is just to give you a very brief, I mean, just to help you understand where, as a VLSI engineer, where do you sit in the hierarchy? Tell me, where do you sit in the hierarchy? At the top of the hierarchy or bottom of the hierarchy? What does VLSI engineer does in this? Tell me. If I tell you these are the four hierarchies, where is the role of VLSI engineer? Please tell me. Bottommost. I mean, he is responsible for manufacturing.
Hardware.
He is the one who makes sure that the hardware gets developed. Okay. So for those who are not able to follow, let me give you a quick recap. So the mobile phone that is there in your hands, the one which you're using, consists of 4 different elements. That's what makes up the mobile phone. At very basic level, there is a hardware, what you see. Okay. Then there are things you don't see actually. Right? Hardware we can easily see because it's a physical entity. On top of that, what is there? A drivers. What is meant by drivers is like when you, I will give you an example of a driver. When you connect your pen drive into laptop, what does it do? It looks for some drivers and it installs the drivers, and then it will tell you that you have connected a SanDisk SanDisk pen drive, 32 gigabyte capacity, like that it will tell you. That all work is done by the drivers. Then on top of drivers, there's an operating system. Operating system consists of kernel and various things. Then on operating system, what is there? You develop the applications, you install the applications and everything. So the VLSI engineer responsibility is to develop the hardware. The embedded system engineer responsibility will be to develop the drivers. Then there are people who develop operating system, people who develop the applications. Okay, let's say you go to Infosys, they are developing a banking software. Where do they fit into this flow? Do they fit into hardware, drivers, operating system, or application? It becomes kind of application only, right? It's the application which is supposed to be working on top of the operating system. So I hope by now everyone has understood what are the various levels. Now what we are going to talk about is we are going to talk about hardware, because those people who are attending this demo session probably are not much interested in these 3 things. So we will now get into what goes into hardware manufacturing. Hardware manufacturing is very complex and lot more different from the other domains. hardware manufacturing is significantly different from other domains. Why is it different? Is in other domains, there is always a chance for redoing the things. Let's say you developed one application, Play Store application, and it is behaving wrongly. Possible, right? Something is behaving wrongly. Okay, there is always a chance for the person to do the update and release the application again. Possible, right? In hardware, it is not possible. It is one-time process. Once you have manufactured, you cannot really redo it. Why we cannot redo it? A hardware is made up of transistors, not one, not two, billions of transistors, which are manufactured into the silicon. So once you have manufactured, if there is any fault in the chip, you cannot redo it. You have to go through the entire process again. That's where this process is. At every stage we do the checks. At every stage, like you are doing RTL integration, there will be a checks to check whether integration is done properly or not. Let's say you are doing functional verification, again there will be a checks. Even on the verification itself, there will be a checks. Whether have we done the functional verification properly. Let's say you have done DFT at RTL level, there will be a checks. Because the reason is, even if one mistake happens, we are talking about one connection goes wrong out of 1 billion. 1 billion means how many? 100 crores. Out of 100 crores, even if one connection goes wrong, the whole chip will not work properly. Some or other place, the fault will show. Then the chip will not function properly. So that is where they have come up with a very structured process where they divide the process into various stages, and at every stage there will be checks to see whether things have been done properly. Okay, so this is about a top level overview of what happens into the hardware manufacturing. Now, from a fresher training perspective, what we do is, as I said before, if I tell you these many domains are there, which domain you want to undergo training, it will be confusing for you to decide. Rather, what we do is we divide the whole training into two parts. Anything above synthesis, we call it as front-end domain. Anything after synthesis is called as back-end domain. Of course, gate level simulation would be part of front-end domain, okay, except for that. Okay. Now, what happens in the front-end domain is, initially you start off with the requirements. Your idea was to do what? Manufacture the mobile phone. So you start off with requirements. Like there will be a dedicated team who will gather the requirements. Requirements means what? What kind of mobile phone is required? What should be the processor configuration? What should be the display configuration? What should be the USB port configuration? Should we use USB 3.2? Should we use USB 4? Inside there will be PCI Express. What type of PCI Express should we use? Okay. All these terms you will get familiar as we go forward. Okay. These requirements are given as input to the architecture team. Gets requirements as inputs. Who has collected the requirements? The team before that. It's a marketing team or someone. Then what does this architecture team will do? They will give you architecture diagram and the detailed top level specifications. It is similar to house construction. You first, whom do you go to when you want to construct a house? First you list down your requirements. You go to the architect. You go to the architect. He will give you the architecture diagram and he will give you the top level specifications for everything. What should be the size of each beam, each column, everything he will give you, right? Then these requirements, whom do you go to? There will be a Mestri or contractor, whom you go. So that team is like this one. What do? They take, for them inputs is what? Architecture diagram and top level specification become the inputs. What is that they develop? They use Verilog language, Verilog or VHDL language to develop the RTL code. By using the architecture diagram, by using the documents, the detailed documents which tell how the design should work, they develop a Verilog or VHDL language based code. RTL here stands for
Hello.
Registry Transfer Level.
Hello, sir.
Yeah, please tell me.
Sorry for disturbing. Actually, sir, somewhere I read that now VSDL language is not in use, like Verilog is used. So, is there any type of means that thing like VSDL is not in use?
See, it's mostly like US based companies use Verilog. Europe based companies. Now, even these companies are transitioning. I mean, these companies are also transitioning to Verilog. But legacy codes will be there. What is meant by legacy? Something that has been already developed 5 years ago in VHDL. Would you again take effort to change it to VHDL? Verilog? No, right? So whatever is already there, they will keep it in VHDL only. But if they develop any new projects from scratch, they may do it in Verilog. But if you ask me, is VHDL language not there? No one is using. The answer is no. People are using VHDL also. The ratio could be, it's like 90% of the companies could be Verilog. 10% could be, because VHDL is also a very powerful coding language from RTL coding perspective. I
Sir,
hope you,
Verilog is popular than VSDL.
Verilog is popular than VHDL, of course, yes. No, I didn't say popular, I said powerful. VHDL has lot of features for RTL coding purpose. I didn't say popular, I said powerful. So what happened during the RTL coding? If you, I mean, just to understand RTL coding, if we go to I just go to any SOP architecture. See this diagram. This diagram shows you an architecture diagram. One diagram, you see here various components. What do you see in this diagram? There is one RISC-V core is there. Then there is a vector accelerator is there. DSP chain, different components. Okay, don't try to understand what is what. Okay, this diagram is what we call as an architecture. This diagram is what we call as an architecture. That shows you how the connections are to be done, what all components are inside each one, and what is the crossbar, and how each thing is connected. It will show you. What is RTL design engineer does? RTL design engineer develops these components separately. He develops these components behavior using Verilog or VHDL language. So what he has done? He has developed each of them individually. Like this is the first one he has developed. 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that, if you draw, there may be around 50 numbers. If you draw if you give numbering for each block, how many numbers you may get? Roughly 50 numbers. These 50 files will be integrated to get a complete code. Integration means what? Connecting with each other. So that work will be done by whom? Whom do you think will do that work in this flow? You have done requirements, architecture, RTL coding, RTL integration. Whom you think will do that work of integrating everything? What integrator will do? Let's say there are 5 people here in this room. Each of them are 10 people. For each of them, we give one block. You develop RISC-V code. You develop accelerator code. You develop PC Express code. So each of you will develop. I will take the blocks. I will take your code. I will connect each of them to come up with one final complete. This being called as the SoC, system on chip. Each of these, like, what is it like? Going back to education system, one of them was like a principal, one of them was like a lecturer, one of them was like a student, one of them is like an admin, one of them is like some support staff. Putting together everyone, connecting their functionalities is what we get is a system. Since we are talking about a VLSI, it's called as a system on chip. That work is done by RTL integration engineer. Now there can be in this whole process things can go wrong, right? One is you may have coded something wrongly. Some functionally some mistake you might have done. Instead of writing plus, you may have written minus. Some logic itself you would have missed. Or during the connection also I might have missed. Let's say these are the expected connections to be done. By mistake, what has been done? This has been connected to this. This has been connected to this. Isn't it possible? During the connections, it's possible, right? You are just connecting the code. It is possible. So the process of checking whether everything is coded properly or the connections done properly is called as functional verification. What is functional verification? Checking whether RTL code is working as per the design specifications. What is functional verification? Like there is a design specification here, and there is a teams who have developed the RTL code. This is one input. This is second input. Do you see that there are two things here? One is a document which tells how my design should behave. Then there is a code which has been developed as per that. Then what do? We call a third person to check both of them. Check whether spec and RTL code are matching with each other. Who is the person who does that? Functional verification engineer. So what is the languages he uses? He uses languages called as system verilog and UVM to develop the test bench for verification purpose. What does he do? He uses system verilog and UVM to develop the test bench for verification purpose, and using that he verifies. Now, how does he develop test bench and how he verifies is what constitutes the 6.5 months course. So I can't explain everything in a 5-10 minutes. Just understand that there are dedicated languages like system verilog and UVM to do this process. Once it is done, we go through a process called as DFT. DFT stands for design for testability. What exactly DFT does is, if someone someone knows DFT, can you tell what do you think DFT is about? So in DFT, what do we do is, when we develop a chip, we are talking about into a small area. Let's assume this is a chip area, fitting in 100 crore transistors. You know what each transistor is like, right? A transistor, if you take a MOSFET, it has got gate, drain, source, and base. Like this, how many are going into this chip? 100 crores of such things are going. Now, when you are doing these connections, there is a possibility that this is supposed to be assumed. This is supposed to be connected to VDD. This is supposed to be connected to a ground. For example, assume due to something, this also got connected to VDD. It was supposed to connect to something else. What happened? Because we are manufacturing at a small, very small level. What is the level we are manufacturing? Nanometer level. What can happen? There is a metal got deposited here. Some metal got spilled over. It's the metal depositions, right? That's how chip gets happened. These two got shorted. What will happen? Will this transistor work properly in that case? No, right? It won't work. Is it something to do with my RTL coding? This fault, is it something to do with my RTL coding? No, right? Absolutely not related. Because my RTL coding is something else. It's related to the coding and functionality. This is related to the manufacturing. So the faults can be two types. One is functional faults. The something mistake is done at the coding level. Second is what? Manufacturing defects, manufacturing faults, where due to the manufacturing technology, some faults can happen to the chip. That is, here you see they get shorted, even this gets shorted. I'm just telling you a possible mistake that can happen, right? Okay, some output is supposed to be at ground, it got connected to VDD. So there can be many things. There are other faults like stuck at 1 fault, stuck at 0 faults, at speed faults. There are multiple types of faults. Now, if I tell you that this is the mobile phone, this is the chip, can you tell me will it be possible for you to see and tell me that this phone has a fault, this phone is working fine without doing anything? No, right? It's not possible. Just looking at the chip, it is not possible to tell whether this chip is good, this chip is bad. I cannot tell. So what will you do if I give you mobile phone and tell me whether it is good or faulty? What will you do? Tell me roughly. I mean, just make a guess. What will you do? And definitely you will not see and tell that it is good, it is bad. You can't tell that. What will you do? What will you do? You take the mobile phone. You apply. You do something on the mobile phone. You try to use. You'll make a call. First thing. Second, you will send an SMS. Third, what will you do? You'll try to install some applications. Fourth, you'll try to check all the keypad whether it's working or not. Like that, there is some inputs that you're going to apply. You're going to apply some inputs, and the behavior of the mobile phone will tell you whether it's working fine or not. The same thing happens at every level. Even in functional verification, you exactly do the same thing. What do? You apply some inputs to the phone. But the thing is different. What is different here is that in case of functional verification, this is not a physical unit. This is actually a code. It's a very long code to which you apply the inputs and then you check the outputs. When it comes to manufacturing defects, will there be any manufacturing defects in Verilog code? If I tell you that this is 100 lines of Verilog code, will there be any manufacturing defects in that? No, right? Code cannot have manufacturing defects. Where will you get the manufacturing defects? Manufacturing defects will come after the fabrication. Once the chip has been fabricated, inside the fabricated chip, there will be manufacturing defects. So that means there are two types of testing that happen. So if you go to some companies, they call it as pre-silicon validation. Some companies call it as validation is two types. Or you call it as validation or sometimes verification. It's called as pre-silicon validation. What should be the other one? Post-silicon validation. So the post-silicon validation is something to do with the checking already manufactured chip. Checking the chip behavior while it is in a coding form, while it is in code form. It's what very long. Here we don't have the chip. And checking the coding level, is it working fine or not? That's why it's called as pre-silicon. The term pre-silicon means what? Before the silicon got manufactured. Please be mute those attending online. Checking the chip, like pre-silicon means what? Before the silicon came into picture. Means what? It was still in the coding level only. When does the silicon come into picture? Fabrication, right? When you send it to the foundry, it gets manufactured and then you get the chip. Whatever you do after that, it's called as what? Post silicon validation. So in both the cases, concept is simple. Validation means simple concept. Remember throughout this 6-7 months of training, you have a design. It can be a code. It can be a chip. Anything. What do you do? Am I audible now?
Yes, sir. Now audible.
So I was uh, your chip functionality into multiple parts. Like I was giving you a simple example of keyboard. Now keyboard can be checked two ways. It can be checked. It can be checked in two ways. Okay. So I was telling you that a keyboard can be checked in two ways. One is randomly type the keys. Second is what? Divide whole keys into categories. Then check each category. Like what is an example? Number keys, alphabets, function keys. Which one is better? First one or second? Second one is better, where you know where the things are going wrong. Whether you know whether number keys are not working, whether alphabets are not working, whether functions are not working. This is what we exactly do in validation also. We don't randomly do something. You take a chip, you don't apply inputs randomly. You follow a process where you know what to check, what you are going to target, and that check whether it's working fine. That is about validation. Now coming back to our discussion. So where did we start all this? We started all this while discussing about the DFT. I told you that what is exactly DFT stands for? Design for testability. And what do you do as part of the DFT? We develop scenario or something called as test pattern to check for manufacturing defects. What do we do? The DFT engineer develops test pattern to check the manufacturing defects. Okay, what does functional verification engineer does? He develops test pattern, test cases to check the functional defects. So functional verification targets functional defects. DFT engineer targets what? Manufacturing defects. In both the cases, they are going to develop some test scenario. These test patterns, okay, whereas verification engineer, what he develops is called as test cases. Let's make a small XLS so that you can easily understand what I'm talking about. Then once it is done, I will spend another 15 minutes and I'll just give you the brief overview. Okay. Once this is done, has everyone got a basic idea about what is functional verification, what is this thing, DFT? So what I was trying to tell is that in case of, if I write functional verification, on the other side, if I write DFT, functional verification is done at the RTL level, while the code in the Verilog code level, whereas the DFT checking is done at the post-silicon level, and once the chip has been manufactured. So what is the target for functional verification? Functional defects. What is the target for DFT? Manufacturing defects. These, what functional verification engineer develops is called as test cases. What DFT engineer develops is called as test patterns. This at a very basic level. This is called as pre-silicon validation. This is called as what? This is part of the post-silicon validation. Then once the silicon has manufactured, validation you do is the post-silicon validation. So this is majorly the difference between functional verification and DFT. Now once it is done, you go to a next major step called as synthesis. What exactly is synthesis? Is converting the RTL code into gate level format. Till now it was at the Verilog level. Verilog means what? Always at the rate of positive edge of clock. If this is the case, do this, else do this. Or case statement, assign statement. That is how it was at the RTL level. Now gate level means what? AND gate, OR gate, NAND gate, NOR gate, that level. Converting that into that level. I'll give you a simple example of what is meant by synthesis. If you write, are you all familiar with D flip-flop? Okay, what does D flip-flop behave like? At every positive edge of the clock, at any positive edge of the clock, whatever is the value of the input, D input, it is captured to Q output. So how do you write the Verilog code for that? You write module D flip-flop, clock, reset, D, Q. Then you write input, clock, reset, and D, output, reg Q. Then you write always at the rate of positive edge of clock, begin, end. Then you write what? If reset equal to 1, Q equal to 0, else Q equal to D. This is what you do. This is the Verilog code. This is what I mean by RTL code, register transfer level code. The other format of this code will be gate level. You go to just Google and search the gate level implementation of D flip flop. The gate level implementation of D flip flop. Just go here, D flip flop, gate level implementation. Okay. You will get some circuit with 8 NAND gates, 2 NOT gates, like that. One of the things could be what? At gate level will be what? D flip flop. At gate level will be 8 NAND gates plus 2 NOT gates, or something like that. You will get essentially, right? It could. There are of course other implementations. I'm just talking about one of the possible implementations. So the process of converting this code into this format is what we call as synthesis. You may say this is very simple, I can do it. But the problem is at bigger level, my Verilog code will be lakhs of lines. It will consist of lakhs of lines, and converting that manually into this format is very difficult. So that is where we use the tools called as synthesis tools called as design compiler, genus. Those tools will do the conversion. They have some algorithms inside them which knows how to do the conversion. That's at very top level how synthesis is done. Okay, once you have done, now the next work is what? You have got billions of transistors, billions of gates. They need to be fit into a small area. They need to be fit into a small area. Like when you open a mobile phone, you may get 1 square centimeter of chip, or maybe 2 square centimeter of chip. That is this one. Into this, that 100 crore or 1 billion transistors. That process is called as PNR flow, placement and routing flow. P stands for what? Placement. N stands for and R stands for route, right? Placement and route flow. Then during that they do some static timing analysis. Then they do some IR drop analysis. Then finally to check whether everything is done properly or not, they do physical verification. Then finally they do layout. I think we need that important step. Once it is done, they do layout. Then we have fabrication, post silicon validation, and packages. Okay, so I won't go deep into it because I assume that most of you are attending the front-end domain, that is functional verification or related domain. So hence, I don't want to go deep into it. This is also equally challenging. It's not like it is easy, or it's not like very difficult. Each domain in VLSI has its own share of difficulty and share of easiness. Okay, because why it's difficult? You're trying to fit in 1 billion transistors into 1 square centimeter. So it's very challenging, right? Like imagine you have a table and you are trying to place 10 elements on that. 1 notebook, 1 pen, 1 laptop. Just on a table you are trying to arrange 10 things. It is possible. What if I give you 100 things to arrange? It's still possible. What if I give you 1,000 things? It's very difficult, right? Now then you start placing what should I keep here? What should I keep here? Now imagine 100 crore. What is 100 crore? 9 zeros. That you are trying to fit into a very small area like 1 square centimeter. That is where challenge is there. There we have to ensure that there is no timing violations. Timing violation means setup time and hold time should be proper, should not violate. Then the voltage should not drop too much. What is meant by IR drop? I'll just give you a simple example of what is IR drop. There is your house is there. Outside the house, these poles will be there, right? From where you take your connection to your house. It so happened that you're connected a kind of wire which is taking 230 volts here. By the time, what is the voltage that should come to your house ideally? 230 volts it should come. The wire is such that the voltage that is coming to your house is 130 volts. Why do you think that 130 volt has come? Due to the resistance here, the voltage got dropped. Right? When there is a resistance, what happens? As the current flows, IR drop will happen. Right? I means what? Current. R means what? Resistance. So this resistance will drop the voltage. Generally, it won't happen. Generally, if you check your house voltage, it won't be 130 volts. It will be somewhere around 210 to 220 volts, accounting for the drop in the voltage. They inside the chip also they have to do everything like that. They have to check whether the voltage is at each point voltage is proper or not. Because if there is a low voltage, what will happen to your house appliances? What will happen? Like just now blinking happened. Same thing will happen. The refrigerator won't work properly, right? Things won't work properly. The heaters won't work properly because they need some minimum voltage level for everything to work. Same is the concern in the chip also. For chip inside the chip, at each point, a minimum voltage level is required. During IR drop analysis, they check whether the drop is sufficient, is manageable or not. Like that, there are a lot of things. I will say it again, let's not get deep into this. It is all part of a back-end flow discussion. So why we are discussing about all these things is to give you a brief about what is front-end domain, what is back-end domain. So just to quickly summarize, we discussed that the entire VLSI design flow can be divided into two major parts. One is front-end domain, one is back-end domain. Now, what is about front-end domain is, it is mostly programming oriented job. Back-end domain is mostly tool and technology oriented job. What is meant by programming oriented job? Something similar to what a software engineer does. What a software engineer does, he takes a document, he understands the algorithm, he implements that using C or C++ languages. Similar to that, a VLSI engineer understands the document, architecture, and the specification. He implements it using Verilog system. So you need expertise with Verilog and system. For a backend domain engineer, he doesn't work at Verilog level because by the time he reaches here, see if you go back to this flow, once you have done with synthesis, do you have Verilog from this point onwards? No, right? Because the Verilog code has converted into gate level code. So this person, people who work from here onwards, they don't have anything to do. They don't have much to do with Verilog. Not that they should not know anything at all, right? Some basic idea is required, right? But they don't need to go deep into Verilog. But people before this need to be good with Verilog. Need to be good with system Verilog. So that is the major difference. So why this is important for you? Because based on your prior knowledge, prior understanding, you should make a decision. Do I want to get into a programming based job or do I want to get into a tool and technology oriented job? What exactly is tool and technology oriented job? Tool means what? There will be some software you need to learn on how to automate the things, how to automate the flow. What is meant by that? I'll give you a simple example. Tool, like in some of your friends might have studied mechanical engineering, or even during your BTech, during first year you would have studied engineering design. Which tool do we use during engineering design? Something like CAD tool, like ArcCAD, some tools we use, right? What those tools will do, they will try to help you draw the side picture, the top position, different views of the same image that finally gets manufactured. So you use tool to do that. Rather than what is the other way to do? You manually take a scale and draw everything, right? Rather, what is the second way? Use the tool to do that. Same you do in the VLSI also. Not that you will draw the things here. What you could do manually, instead of doing it manually, you use the tool to do it. What is the tool can do for you? If you want to draw a rectangle of this shape, you just tell that I want rectangle of this shape, it will immediately give you. Rather than you taking a scale, draw this line, draw this line, draw this line, this line. The tool will immediately give you. Let's say you say I want hexagon, length of 1 centimeter. It will immediately give you something like this. Again, you may be thinking, are we going to do mechanical engineering in VLSI? I'm just trying to tell you what is meant by tool expertise. How to use the tool to do the things in a simpler manner. That's what is. You're not going to draw a hexagon, you're not going to draw a rectangle. Just a simple correlation. What is meant by technology here? Like, how does 10 nanometer technology works? How does a silicon based MOSFETs work? What is meant by drain? What is meant by gate? What is meant by source? What is substrate? What is short channel effect? What is the drain induced barrier lowering? There are many such technical terms, short channel effects, everything, right? So you should be, this person who works in the backend domain should be good with all those understanding. What is meant by IC fabrication? What is meant by lithography? What is meant by etching? What is meant by oxidation? To that level, they should understand. A person in front-end domain don't need to know anything at all, those things. Because a front-end domain engineer doesn't deal with silicon. He doesn't deal with MOSFET. He only deals at coding level. So this is a brief difference between front-end domain and back-end domain, right? So this should be the starting point where you make a decision. Do I want to get into front-end domain? Do I want to get into back-end? Any questions so far? I hope you got a bigger level picture. So where did we start our entire discussion with? We started our entire discussion with taking one electronic system. We understood that what is the electronic system has got 4 elements that make up: hardware, firmware, operating system, and application. And we discussed that VLSI engineer is the one who works into development of the hardware. He doesn't bother about software. He doesn't bother about the application, anything. Okay. Next, in VLSI, again, manufacturing chip is more difficult than other things because other places you have option to correct the things. Let's say you have developed a software. Let's say even Microsoft has developed an operating system. Does it happen in one go? No, right? What happens? Every 1 week they'll keep asking you to upgrade, right? Every 1 week, 2 weeks they'll say upgrade. That means what? They have done some updates or something. They have such flexibility. Anything that works at the coding level has such flexibility. Whereas anything that done at the hardware level don't have such flexibility. You have to do it one time and that has to be the right thing. That is where VLSI flow is little more complex than other things because other things has some margin of error. You can do mistakes and you can still correct it. But in VLSI, margin of error is very minimal. That is where they have divided the entire flow into a very detailed stages. I give you an example, right? IR drop analysis is important. Don't you think it's important? Let's you construct a very big house, and finally you see that lights are not glowing properly. Your heaters are not working. Will there be any use of such house? No, right? Then what you should do? You should call electrician. You should ask where the drop is happening, why the voltage is not coming proper. The problem in chips is you cannot do once it has been manufactured. Once manufactured, done. So it has to be checked at each stage, has it been done properly? So that is where the whole flow is divided into almost 20 steps. Small steps, 20 steps. But to do every step, there is one engineer, DFT engineer, RTL design engineer, RTL functional verification engineer, RTL integration engineer, synthesis engineer, physical design engineer, like that. So then what did we do? Instead of confusing you to take just a 1 out of 20, we discussed that we divide the entire flow into 2 major parts. One is front-end domain, one is back-end domain. When do you go for front-end domain? If you are interested in programming-oriented job, you go for front-end domain. When do you go for back-end domain? If you are not interested in programming and if you are more interested in the technology, tool and technology wise, You are comfortable with using the tool, how to work with the tool, like what options, what does this option mean, how do you use different options. That kind of exploration you have to do the tools, right? That kind of thing, if you are interested in, then you go for backend domain roles. We will talk another 10 minutes. We'll continue and take a break. Okay. Okay. Job opportunities wise, there will be opportunities in every domain. I mean, it's not like front end has more jobs or backend has more jobs. But I can tell you in a relative terms. In last 1 year, I have seen more opportunities for front end domain compared to backend. Relatively more. Now, why is it important? I mean, how does it work? How does this job distribution work? Let us quickly talk. If there is a team has around 100 people, what is the team we are talking about? Let's talk about a Qualcomm developing a mobile phone chip. Can one person do the entire chip? Not possible, right? It requires a group of people. That's what we are calling as a team. These 100 people may be divided as around 60 people into front-end domain, around 40 people into backend. There are distribution. Okay, now it could be 50-50, it could be some other way also. Generally, it might be the possibility into backend domain. This front-end domain, RTL design may have only 3 to 4. RTL integration may have again 3 to 4. Functional verification could have almost 30 to 40. There is again a scope for different numbers. Okay, this instead of 3 to 4, it could be 6 to 7 also. This could also be 6 to 7. I'm just giving a rough numbers. Okay. Don't literally take those numbers. What is the idea I'm trying to convey to you is that functional verification requires more people compared to other. That's the baseline. Now, will it be exactly if you go to Qualcomm and ask, do you have 4 people in your team? No, that need not be the case. It can be 7-8 people in the team, right? Similarly, going back to other domains, like in DFT, there could be here, the DFT we place it under, let's say, backend domain. There could be 5 to 6 people. The PD can be 20 to 30. STA could be 5 to 10 people. Layout can be 5 to 10 people. Again, where do you see more opportunities in backend also? That is where you see companies hiring a lot of people in functional verification domain, lot of people in physical design. Then you may say, what about RTL design? Can I do training in RTL design and get job? Generally, what happens is 3 to 4 people will be mostly experienced. This will also be mostly experienced. This is mostly experienced. When it comes to 30-40 people, what they do is mix of freshers plus experienced. Freshers plus experience. This is also freshers plus experience. Because this is the very important aspect. Now, fresher cannot do the work of experience the way experience can deliver. Whereas in functional verification, what happens is since there are 30 to 40 people, there's always a chance to give some part of the work to a fresher and then let him come up to the experienced person in 1 or 2 years. There you see a lot of people getting hired in functional verification, a lot of people getting hired in PD. And then yes, some people do get hired in DFT layouts. Right? So that is where you see, if you see the opportunities for freshers, this one and a lot of institutes you will see offering only this course only. One is functional verification course, one is physical design course. Even if you say I will do DFT course, what is chance of me getting a job? There is a very good chance. Even though then you may say there are only 5 to 6 people here, 5 to 6 requirements, whereas in DFPD there are 20 to 30. So here the difference will be, the ratio is very big. In PD, for these 20 to 30, I'm just giving you an example. 200 people are getting trained. Just an estimate, okay? Maybe 100 people are getting trained. For same 5 to 6, here probably 20 people are getting trained. Which one has a better chance? This is 100 by 20. This is 20 by 5. Just a rough idea, okay? Do not take the numbers as it is. The point is the domain where there are less opportunities, less number of people required. Very few people undergo training. In PD domain where there are more opportunities, there are a lot more people who join for the training. Going by that, even in the functional verification also, of course, a lot of people undergo training. I mean, you know that every institute you think of has functional verification. But even opportunities are like that. Today, the scenario is that in our institute, there is almost no one who needs job. Functional verification, except for 2-3 people who don't really do anything, except for few people who don't have that willingness to learn. Almost everyone is getting job. So why did I give this distribution? To tell you that why do people hire freshers in functional verification? Why do companies hire people in physical design? Now, if you ask me, I will get into functional verification. Can't I get into other domains afterwards? Yes, you can always get in. Let's say you join now this one. After 2 years, you can always move into RTL design and integration. And also, it's not like this is a low category of work or anything. Everything is equally challenging. Functional verification is also an equally challenging work, because as much as what RTL design engineer need to do, he has to understand the design, understand the behavior, everything. Even a functional verification engineer needs to understand everything to that depth. So hence, every domain is interesting. So this is a brief about it. But my personal experience has been that this I have seen a lot of opportunities compared to physical design. That's where I say that in functional verification, I don't even have 2 or 3 people today. Also, if a company comes, many times people keep calling me, telling me that just give me a few people. I have to tell them that maybe I will check 1 or 2 people I may have to check. And even like people are talking about slowdown right now, recession slowdown. Even now we are getting almost almost every 2-3 days 1 or 2 companies do come. Even as of today. That's not the level of hiring that happens in backend. If you ask me in physical design how many opportunities I bring in, probably in a week two companies may approach in functional verification. Almost 1 company a day does. So this brief about it. So now what we will do is we will just give a brief overview of the course structure and then take a break. The course will be for 28 weeks. The functional verification course is for 28 weeks, around 28 to 30 weeks, I would say. We divide this 28 to 30 weeks course into 3 parts: phase 1, phase 2, phase 3. The phase 1 is majorly focused on fundamentals like digital design, advanced digital design. Okay. And GV, Linux basics. This is what phase 1 is focused on. This would go for around 10 weeks. How this is divided? Around 3 weeks for digital design, remaining 7 weeks for this. Phase 2 is where we cover the advanced aspects, system Verilog and UV. Then Here we teach advanced levels. This would go for around 12 weeks. So totally how many weeks is taking phase 1 and phase 2? 22 weeks it's taking. 22 weeks is roughly 5 months, right? By these 5 months, you're ready for that. You can apply for it. You can start applying. Because companies majorly expects you to be expert with this. The phase 3 is the project phase, where we do the AXI UVC development, AXI protocol and UVC development. Then one industry standard project like Ethernet, MAC, functional verification. Then once it is done, we teach the concepts of Python scripting. Then a top level overview of it. Then version control management. These topics. This would go for almost 8 weeks, 8 to 10 weeks. Now you may say it totally adds to 32 weeks. Going by that, it adds to 32 weeks. We don't have to bother much with this. As long as this completes in time for you, rest should not bother. Why? Because if you are looking for a job, you can start looking for a job after 5 months, immediately after 5 months. By that time, digital Verilog, system Verilog, UVM is done, which is the 80% of the decision making. The phase 3, whether you take more time, you take much better is for you. Instead of taking 10 weeks, if you take 20 weeks, it's even better because you can do the projects in more depth. Lot more depth, right? I mean that roughly the calculation would be it will go for 2 weeks, it will go for 4 weeks, this will go for 1 week. Remaining things will go for 1 week. I think 1 week we finish up. With the whole remaining thing itself can be completed in 1 week. So roughly this is adding to how much? 8 weeks. What we might do is instead of 4 weeks, we may give you 6 weeks total. That's where the 8 is extending to 10. My point is at this stage, I don't really bother because you are anyway able to apply for the job. There's a chance that you may get a job. Even after getting into the job, you can still do this training, either through recorded videos or by attending the live training. One of those things. Even companies do allow. I have some students who got job after phase 2 and they are still doing my training. They are part of the training. They are part of a company and they are still doing the training. Our point is what? If I ask you to wait for 8 months and then you start applying for jobs, that will be a problem, right? Because 8 months you have to wait and then apply for job is a problem. Rather, what we do is we finish off the important things that is really required for you to apply for the job within 5 months. Then remaining things we do at a relaxed pace. Relaxed pace doesn't mean that one session in a week, like no. 6 days the sessions will happen, but in a more depth, much more depth. I mean, I think this might not my laptop. For one of the project, I have done almost 30, 33, 34, 32 sessions I have done. 32 sessions roughly add up to close to 6 weeks. In 1 week. In another batch, I had done 5 weeks like that. The point is, once I know that you are all comfortable, I mean, you can start applying for the job. We don't really bother much about the timelines. We rather worry about, are you able to follow the things or not? Are you able to do the things or not? What is the final goal of this whole 28 to 30 weeks would be is that you should be able to do the things independently. Let's say when you go to a job, you join, for example, Wipro. Okay, and you are reporting to a lead. You don't want a scenario where each and every small things you go to your lead and ask how to do this, how to read this document, how to understand this. Then what will happen? What is the best thing in that case? Instead of you doing, the lead itself can do everything, right? Manager himself can do everything for you. If you go and ask him everything and how to do this, how to do this, how to code this, how to run this. This training is to prepare you for that, to a scenario where you become independent. while doing the things. So let's say you're going to learn Verilog. Tomorrow you're not going to do the same thing in your company. You may not exactly do the same Verilog work. Let's say I teach you asynchronous pipe. I teach you SPI controller. You probably will not be doing SPI controller, or you probably won't be doing asynchronous FIFO in the company in Wipro. Rather, you will be doing the activity which this will help you there. How to understand the problem, how to come up with a solution, how to implement the solution. That's how we should look at it. You got the idea, right? So idea is to make you independent. As of today, as a fresher, when you come, you are dependent on everything for that matter. How to start coding, how to run the tool, everything you are dependent. So this course will enable you to become good with Linux, good with SP and UVM, to figure out how to develop the code, how to understand the code, how to run it, how to find the defects, how to debug. And can this be only one-sided effort where I am only teaching and you are not doing anything? No, right? My effort has to be 30%. Your effort has to be 70%, right? Only then learning will happen. If I give 70% and you give 30% also, it won't work. Major effort has to come from your side. My effort would be to give you the right direction. As a trainer, it need not be me, my other trainers. Our effort is to give you the right direction, what to learn, how to understand things, how to prepare. And initially how it works is, during this period, lot more support will be there. Means for every line, each and every word, each and every line, you get a support. That support will come down a little bit here, where you should start doing things more independently. Here, the support further comes down. Idea is to make you independent, so that you learn the things and how to do it in the right manner. So this is how the course has been structured. Now this 28 weeks course will be offered in both classroom and online. Also, you can go for e-learning. You can attend full week training, weekends only training also. If it is full week training, it will be for 6 days per week. This is mostly targeted for whom? Freshers. This is mostly targeted for experienced people, right? 6 days per week. Training will be from 9:30 a.m. to 1:30 p.m. Weekends only training will be mostly, will be 2 days, 2 weekend days, and training will be again same 9:30 a.m. to 1:30 p.m. kind of times. Now you may say the next question comes, can we cover everything in this 8 hours? Rather, what we do is access to all the course videos for entire course duration. You are supposed to, it's like a weekend only training is a mix of recorded videos plus live training. You go through the videos, like trainer will give you schedule. Trainer provides learning schedule. Trainer will tell you that during this week you have to complete these videos. Then over the weekends, corresponding topics will be discussed. Whereas in full week training, there is no such thing. I mean, because everything will be live. And here also, every session video provided for 10 days duration. Let's say you are attending, this session is also being recorded. This video will be accessible to you for next 10 days. Let's say tomorrow's session for another 10 days. Whereas in weekends only training, it's entire course duration. Because they are not attending live, so they will be given more flexibility to watch the videos at their own convenience. So this is a brief about it. And these training will be alternate theory and lab sessions. Alternate day. Let's say today is a theory session, tomorrow will be the lab session. And yeah, let's now take a break around 1 hour, 1.5 hours we are done. Let's take a 10 minutes break. We will meet at 11:35 a.m. Once we meet, I will take the question and answers. I mean, whatever questions you have related to the course, I'll clarify those things. So we'll meet at 11:35. Those who have posted their questions in the chat window, I'll be answering all those questions after the break.
This conference will now be recorded.
So let us resume the session. So I have stopped the session while discussing about the course schedule. So I was giving you the schedule for functional verification course, that it is roughly 28, or it can extend up to even 30 weeks. It is divided into two parts: phase 1, phase 2, phase 3. The initial two phases complete the required essentials like digital design, Verilog, system Verilog, UVM, advanced Linux, and the GVim basics, GVim entire. Okay. Then in the final phase, we do the projects. One is industry standard project, one AXI based project, one Python and other things. Even during system Verilog also we do a basic project. To teach language, we use a project. So even during this 12 weeks, there will be some small projects will be. But the focus is not more on the projects. Focus will be more on learning the language. By the time you reach here, you're already good with the languages. So focus will be to learn the concepts, like how the verification is done, how do you develop the test bench, how do you develop test cases, how do you debug, that kind of experience. Then I had told you that the training is offered in classroom and online, and even you can attend a hybrid model. What is hybrid model is, let's say you are currently out of Bangalore and you want to attend 1 month, December month online. From January mid, you want to come to Bangalore and attend off. That is also possible, because for both classroom and online, the schedule is exactly same. Like some of you are attending classroom, some of them are attending online. Is the schedule different for you? No, right? Same schedule. The same is happens in the further sessions also. Now, there will be a structured tracking process of your progress. I mean, we will have the assignments for each and every topic. For every topic.
This is not audible, sir.
Okay. Those attending online, can you hear me now?
Yes, sir. Yes, sir. Now audible.
Yeah. So I was telling you that there will be assignments for each and every topic, and there will be a supporting sessions where the trainer will guide you. And towards the end of each topic, there will be evaluation history. Like as I said, the whole course has multiple topics. At the end of digital design, one evaluation test will be there. At the end of Verilog, there will be one evaluation test. In fact, in Verilog, there will be two evaluation tests. One for the language, one for the projects. This itself is two things. Language plus projects. Similarly for system Verilog, similarly for UVM, each and every topic, there will be evaluation test will be there. And based on that, we suggest, I mean, if someone requires additional support, we provide the additional support to you. And other than that, server software. And uh, and other thing is, you will be getting one assignment Google Drive link to submit assignment solutions, and this will be evaluated regular basis. I mean, there will be a trainer who will be evaluating, and they will be giving the scores to you. And mostly this pretty much completes the thing. And there will be some presentations for each topic. Means what does it mean is, we'll give you a topic, you will have to do a 20 minutes presentation on the topic. Idea is to help you get rid of it, help you become comfortable with how to explain things, because when you go to interview, you're supposed to explain the things to the interviewer. If you don't know how, let's say you have the knowledge, but you don't know how to explain the things, then it is of no use, right? Because ideally you should be able to convey the things to you. Like that, if I do around presentations every month, over the period of time, you would have done 7 presentations, 7 to 8 presentations. That will make you good with overall how to explain the things. First presentation you may not do so well. Second, third, by the time you reach to the last presentation, you will be good. And there will be mock interviews every month. I mean, at least one mock interview every month. Again, all this thing is to encourage you. Okay, let's say you are not doing well, the trainer will give you suggestion where you need to improve. Do you need to improve in your presentation skill? Do you need to improve in the technical skills, or do you have to improve in the programming skills? The trainer will give you. So this is all done to make sure that you are given the required support with the overall learning. Okay. So this is a brief about how the things will be there, the course. Now, if you have any questions, I'll answer those questions. So someone asked a question like, FPGA design flow comes in the front end or back? Second question, you can post your questions in the chat window, or those attending online classroom, you can ask the questions. So those attending online, you can continue to post the questions. I'll answer one by one. Okay. First question: FPGA design flow comes under front end or back end? It happens in both. It comes into both front end and back end. Anything related to coding, let's say to develop FPGA, you need to develop a Verilog code. Then finally, you need to synthesize to get the level netlist. That need to be put onto the FPGA code. So that will become backend. Anything to develop Verilog code will become front. So it comes under both front end and backend. So FPGA design flow is one domain where same engineer need to have expertise with both front end and backend. Whereas when you come to VLSI, it becomes either coding expertise, it either becomes backend expertise. But in FPGA, people require an entire flow expertise. Our course, we do offer a course in FPGA design flow. It gives expertise with both the things: how to develop the design, how to verify it, and how to put it onto the FPGA board also. And that batch also will be starting as part of this course. Okay. And let me tell you, FPGA design is also a good domain. There is a lot of opportunities, and there are not enough people. Why do I say that? If you just search in Google how many FPGA training institutes are there across India, you'll hardly find not more than 5. Okay. But if you ask me, there are only 100 opportunities for FPGA. No, there are many companies working. All this companies which don't manufacture in bulk, right? They always manufacture, they always use FPGA. So there you will always find the opportunities. Today, there is a big gap between the number of people who require an FPGA and number of trained resources. The difference could be as much as there could be 50 people required in the FPGA domain. There are only 10 people available. Many times companies do approach us, but we don't have the candidates at all. Just a rough idea, guess, okay, it could be 3:1, it could be 4:1, but yes, there are definitely more opportunities than the people available in the market for FPGA. Next, I have completed my MTech in signal system. I know a little bit coding because I did software testing course. Which one is good for me? See, what you can do is, since you said you have done a software testing course, you could start with functional verification course. You could try it for 2 months. By the 2 months, you would have completed digital, Linux, GB basics, and 1 month of Verilog. In that 1 month of Verilog, as you know, this initial 1 month is common for everyone. Doesn't matter whether you are front end or back end. That initial 1 month is common. Later 1 month is different. So during this 1 month, you make a decision. If you are able to follow the functional verification, the Verilog, you are comfortable with Verilog, you continue with functional verification course. Otherwise, you switch to PD or DFT, any other domain. So in this whole process, how much time will you be losing? If at all you will be losing, how much time? How much? Only 1 month, because 1 month is anyway common, right? You are not going to repeat digital again. You are not going to repeat. So you will just restart with the course, which is going to start after this topic. So by doing this, you will at least attempt functional verification. If you like it, you continue. Otherwise, you switch to other domain. But the cost of losing 1 month, that is also not like losing. See, 1 month Verilog will help you eventually. Learning some programming is not going to go waste. It's going to always help you. Even vice versa is also possible. You start physical design course, you try for 2 months, you learn all the basics of physical design. If you don't like it, you switch to other domain. That is also possible. If we are choosing DFT weekend classes, what will be the basics training period and advanced? If DFT basics will be for 1.5 months, because all these things you have to do. You don't need to do so much of Verilog. Only 1 week of Verilog is sufficient for DFT engineer. The basics of Verilog is sufficient. 1 week, and more of TCL things like digital, Linux, TCL scripting, and Verilog basics. we might do this for almost 2 months, because assuming a fresher doesn't know anything about Linux, fresher doesn't know anything about TCL scripting, all that, right? We can't just cover it in 2 days and done. We cannot do that, right? I can just teach this is the topics and done without. So what is more important for you, me teaching or you practicing? Practicing is more important. That's where we make sure that we give a lot more time on each and every topic. So hence it will kind of extend for 2 months. Same thing happens in Verilog. Even though when I say Verilog basics, I just don't teach 3 hours and say done. We'll make sure that you know at least basics of it. How to given a multiplexer, how to write a multiplexer, how to write a test bench, how to run it using models in Tool. That much basic you need to understand. Okay. So DFT basics will be for 2 months. DFT main course will be for 4 months. During that time, everything in DFT will be covered. Scan, ATPG, compression, simulations, the BIST, like MBIST, LBIST, JTAG, boundary scan, lot of topics will be there. It will be covered. The one thing I want to tell you is the one we offer in the VLSI Institute is the most elaborate DFT course you get anywhere. I have seen other course structures. Mostly the courses there stops here. Those who are looking for DFT course, mostly the other places I have seen, the course stops at simulation level. And you can even check with the people who may have completed the training there. Where it really differentiates is these topics gets covered in our institute. This is also, these are the important topics as well. Next. And if we are not able to complete the sessions on time, will there be any special classes or sessions conducted? How will be the, see, what is the point is we have been doing this training. This is not the first time we are doing a training, DFT training. This is not the first time we are doing functional efficiency. We keep re-evaluating things. See, initially, if you ask me, this was not a 30 weeks course, or 28 weeks course. We used to do it in 22 weeks initially, 22 or 24 weeks. Then we increased it to 27. Then we increased it to 30. Because idea is to not to complete the things in hurry. Rather, focus should be, our philosophy should be complete only 70%, but do it to the perfection. Rather than trying to do 100%. That's the idea. But that need to be done slowly, because the idea is not that I should just complete the course. The student should learn the things properly and they should be able to do the things independently. Okay. So answer for this question will be yes, we will conduct additional classes as required. How will we be evaluated for each session? Tell me what is the answer. Assignment submission. Right? Many times people copy other people's assignments and submit. Our trainer also checks that also, whether is there any copy in the assignments also, and it's easy to check also, right? So that will also be checked. I mean, if you are at least if the person has basic interest to do the assignments and submit, that's a good indication that he is serious about the training. So the answer for this is assignment submission is more important. I mean, in this whole entire evaluation process for us, what is very important for us is this is very important. We give almost 50% priority, 20% for this, 10% for this, 10% for this. Then finally attendance is 10%. So the maximum emphasis will be on the assignments. By the overall 6.5 months duration, you may be doing almost close to 40 to 50 assignments, a very detailed assignments, not like one line or one page. Some assignments would be as big as 10 pages, with covering each and every aspect. So hence, they will be, that will give you a very good idea about how each student is. Unlock circuit design. Circuit design is mostly to do with what? Tool, right? You don't do manual, you do it using tools. So I would mostly place it at the backend. Because our definition of front end and back end is what? Anything that involves more of a coding is a front-end domain. Anything involves tool and technology is a backend domain. So circuit design is mostly to do with the tools, right? And using technology concepts. It's a backend. Will you provide training certificate for any course? Yes, for every certificate, every course you get certificate. For each and every course you get the certificate. Next, how to download recorded video? It is not allowed. You won't be able to download the video because video, once it goes into the student hand, it doesn't stay with you. It spreads. Then we lose the value of our course. So it is for access purpose. Those in classroom, you don't have any questions. So let me answer these questions. So what is the next one? If some students takes weekdays classes after 1 or 2 months, if they want to switch to their schedule from weekdays, yes, it is possible. Everything is possible as long as it doesn't impact the institute. Basically, everything is possible. Let's say you say you want to switch from weekdays to weekend. It is possible. If you want to switch from weekend to weekdays, it's possible. You're attending live training, you want to switch to e-learning, it's possible. Everything is possible because it's not going to impact the institute basics, right? Institute will function normally as long as it doesn't impact. Let's say you tell me conduct a session at 10 o'clock in the night. I won't do because it impacts the institute flow. When there are many other students who have a problem attending the session at 10 o'clock in the night. So hence that we cannot do. As long as it's going to give you convenience and it's not going to impact the institute and other students, we are going to do that. You switching from weekdays to weekend or weekend to weekdays is not going to hurt anything, so it is possible. Next, what is the period for weekend class and what is the timetable? It's generally weekend class is something that you can do at your convenience. Typically, suggested time is 6.5 months if it is functional verification. But if you say that no, I don't have time, I want to finish it in 9 months, it's also possible. Let's say you say that I have a lot of time, I have time during weekdays in the nights, I can finish it quickly, I can finish in 5 months also. You will get that required support over the weekend. Weekend session is dedicatedly for you, no one else will be there. Only the students who enroll for weekend course will be there. And we can structure the course as per your requirement. Let's say someone is already working and they are fully occupied. Let's say they can't finish it in 6.5 months and they want to do at their own convenience. It's possible, very much possible. I'm not going to tell that your course is extending 9 months, you pay additional fee, not like that. We understand that we have to align for student requirement rather than asking student to align with my requirement, right? Because you may have your own requirements, you are working, you better understand what is your requirement. See, someone may have 25 hours of free time every week. Someone may only have 15 hours and both are attending weekend. Can I ask both of them to do as per same schedule? It's not possible, right? I'll give you flexibility for this person, a different flexibility. I'll give you a different flexibility for this person. That's very much possible. I have people who have done the course for 10 months duration in the institute, and I do have people who have done the course for 3.5 to 4 months also. They finished and they got job also. At the end, for me, there is no big difference. I have the same trainers who have to support them. It's just that little extended period. I don't have any problem. Because the course is for student to benefit out of. The end user is you. You should benefit out of the course. Only then the course has a value. The course has a meaning. Only if it benefits the end user. So we will structure the course as per your convenience. But the suggested timeline is 6.5 months. The same thing applies to classroom students also. Let's say some of you come from a college where you don't know anything. You are not taught with anything. You don't have any basics of Verilog. You don't have basics of digital design. In some cases it happens. Really. I can't expect him to complete everything in 600. Let's say he may want to repeat digital design. He may want to repeat Verilog sometimes. We give you that flexibility. In that case, the course stretches for 8 months or maybe 9 months. It is possible. As long as you don't have a concern, right? Because you, let's say you coming to Bangalore and staying for another 2-3 months is an added cost. As long as you are fine with that, we don't have any problem. Right? There is of course the option to repeat the part of the course. There won't be any additional charges. Let's say you are repeating Verilog, I won't charge anything additional. Next, will you provide any experience certificate for any real-time project? Yes, of course, the certificate of course completion will be there. Certificate of course completion for each and everything. Now, if you say experience, we can give the 6 months intern certificate as required. If we choose RTL design, how many months it will be? RTL design will be for 6 months. The 2 months of basics course, that is the phase 1, phase 2 will be common. Sorry, phase 1. I explained, right, the phase 1 here. This will be common for RTL design because they even RTL design engineers need to do digital design, Verilog, Linux, and GB basics. The final phase will be 4 months will be the RTL design concepts like lint, CDC, RTL integration, the UPL, synthesis, STA, LEC, various topics. That will go for 4 months. Can you explain about physical design course and duration? So the physical design course is again same thing, 6 months course, 2 months of basics training. What is covered in basics training? Digital design, Linux, GVim basics, GVim, and then semiconductors in depth, starting from basics of silicon till FinFET. Then we cover IC fabrication. Then we cover physical design basic concepts. Some basic concepts will be there. What is rise time? What is fall time? What is the macro? Some keywords you need to understand before you move on to the main course. That will be covered in the 2 months basic course. The 4 months main course will cover everything starting from synthesis, the input, setting up project, the placement, the floor plan, power planning, routing, CTS. There are many steps are there. Another 5 to 6 steps will be there. They'll all be covered in the 4 months. Schedule will be same, 9:30 a.m. to 1:30 p.m. But there are times where it can move to afternoon also sometimes, because we cannot do each and every session same time every day, right? Because the same trainer may need to do other courses also. As I have selected Next question, as I've selected e-learning, when will we get the course videos? Ideally, you should have got immediately. Is there any, I mean, the person who asked this question, you should check, there would be one individual WhatsApp group created, in which you will get the login credentials for this portal, www.inskill.in. This portal, you will get the login credentials, and there the videos will be available. Videos, course materials, assignments, presentations will be available. Even the learning schedule will be there, what to do. Like since you are going for e-learning, there will be a learning schedule. I mean, what will be the input for you? What is the input for learning schedule is we ask you, do you have around 15 hours per week? Do you have around 25 hours per week? Or do you have 35 hours per week? Or maybe 35 plus hours per week? Accordingly, we'll give you the schedule. Let's say in this schedule, one course you may take 9 weeks to complete. In this schedule, you may finish it in 7 weeks. In this schedule, you may finish it in 4 weeks, depending upon how much time you have. So we'll give you that schedule also, because I can't give same schedule for everyone, right? Everyone has a different availability of time. Accordingly, we'll give the schedule. That is what you can even see. You will see one schedule also, learning schedule also. That is in case of e-learning. Those attending live training, there is no such different schedule. It's the same schedule we propose. If we choose front end, can we cover all courses in 5 months? It is possible. Now, what is the basic calculation is simple. Someone who don't know anything, assume he came from BTech, but he doesn't know much about digital design, nothing, but he has the time and willingness to learn. Even if you don't have knowledge, but you have willingness to learn, it requires around 600 total hours. How this 600 hours comes into picture is digital design will take around 120 hours. Verilog will take around same 120 hours. System Verilog will again take same 120. Even it could be even longer, 150 hours. UVM can be finished in 60 hours. What else is there? Projects can be done in 150 hours. All projects can be done in 150. Linux can be learned in 30 hours. Python scripting can be done in another 30 hours. You add up roughly how much it comes? 240, 390, 450, 600, 660. So that will be 60. If you start from very fundamentals where you don't know anything, but let's say you're already good with digital design, so this time won't be so much, right? Now, how does this 660 hours translate into? If you spend 6 hours per day, how many days? 110 days. If you can spend 2 hours per day on average, that's all. There is no one number answer. I mean, how many days will it take for me to complete the course? There is no one line, one word answer, one number answer. It depends upon how much time you can spend and what is the quality of time. So it's a 1 hour I'm spending. It can be done one thinking about WhatsApp. You're looking at WhatsApp messages, then you're learning. Then second is what, where you're completely focused and you're learning. There's a difference between both the 1 hours, right? So it's all about that. I'm talking about quality hours. 120 hours should be just focused on digital design, nothing else. This is how it works. Now going by that, you can finish in 5 months. You just have to do the calculations per month. How many? 122 hours or something, right? 132 hours. How do I get 132 hours per month? Roughly 4.5 hours per day. That calculation you have to make sure that you spend that much. Okay. And let me tell you, to get job, even if you perfect this, you do get job. Up till this stage, if you can spend, you will get it. Next, for e-learning, how will be the course structure tracking? Same as live students. See what happens typically when you enroll for the course. We create a WhatsApp group. Okay. Now I don't want to show my WhatsApp, but every student, doesn't matter whether you enroll for a very basic Linux course. Someone enrolls only for basic Linux course. It will go for 2 weeks. For them also we create one individual WhatsApp group. The people who enroll for 7 months courses, for them also we create one individual WhatsApp group. In each group, the group that is dedicatedly for you, there will be a number like VG 7200. That means your enrollment ID is what? Your ID number is 7200. And your group name, what is your course, which month? Let's say December 22. In that, trainer will be there, admin will be there, and you will be there. How many people are there? At minimum 3 people, and sometimes I get added. Someone else might get added to look after whether everything is working. Supervisor, I can say. Person helps you with any technical clarifications. It is for even live students also. If you are attending 6.5 months live training, even for you this group, and there will be admin for providing support with non-technical things. You are not able to watch the videos. You want to request videos or anything, right? It could be you want to request some material. The third person is what? Supervisor, just to look after whether the process is going on fine or not. The fourth person will be the student. So this is how we make sure that you get the support. Now, how does this group help is? It helps you quicker response. Because in a mails, things are delayed, right? I may respond after 1 month or 2 months, 1 day or 2 days also. But in WhatsApp, mostly the response has to happen within 1 to 2 hours. Few hours it has to happen. So this is why we create a group for each and every student. And you know there is no cost for creating groups. And there is no additional cost of supporting, right? Let's say if I, instead of providing support to you after 3 days, if I provide immediate support, things are much better for you, for everyone, right? Because for me, that 1 hour support time is same today also, after 3 days also. But if I provide the support today, you are able to make progress and you are happy. Student is happy. After 3 days, you get support. You are disappointed, but you are okay. So, which is better for me from as an institute perspective? Provide immediate support. So, this supervisor work is to make sure that that gets pushed. The work should be done in such a way that support should happen quickly. So, let's take these questions. For front end, any evening classes? No evening classes because we have permanent staff, most of the people who work, but they are already occupied from 9:30 to 6:30 schedule. So we cannot ask them to again work in the evenings and do the session. 1 or 2 special classes to support can be done always, but no regular evening batches. The problem with evening class is even the who is working, like who generally goes for evening classes, those who are working, and many times work itself is not fixed. Sometimes you may have to stay till 6. Next day you may have to stay till 8 o'clock. So it doesn't work in many cases. Anyway, why we don't do that is we don't get numbers. Hardly 2-3 people will be there for weekend, let's say evening classes. It's not possible to run a dedicated batch for 2-3 people. For functional verification, if we choose weekday and weekend both for complete as early as, so can be finished in 3 months. I told you, right, the same answer, around 600 plus hours. You spend only 2 months and you finish 600 hours, you will be able to finish. You can even finish it in 2 months also, 3 months also. It's all about, will you be able to spend so much quality hours? Next, weekend classroom training is available. Yes, it is available. Every session that happens in the institute, every session happens in both classroom and online. Because is there any additional cost for me? Cost is the only trainer, right? And resources, my laptop remains same. I don't have to use 2 laptops. I don't have to use 2 internet connections. It's all same. So hence, every session you can attend in classroom or online. How do we get study material? General study material is provided. One is a soft copy, one is hard copy. Soft copy, both you will get. Soft copy is something you get by logging into our portal. We have our own learning portal called as InSkill, and that will be providing you with the login credentials. So if I go to one of the courses, very long course. So these are all the courses added into my login. Down if you see, all the courses are added to my login just because I need to review the courses. So in this course, there will be videos, there will be the schedule, learning schedule I told you, right? Based on the student convenience, we give the learning schedule. I mean, do you want to learn in a relaxed pace? Do you want to learn in the normal pace? Do you want to learn in a quick pace? Now, relaxed pace means same course will go for 9 weeks. Normal pace means 6 weeks. Quick pace means you finished in 5 weeks. It would have been ideally 6.5 weeks. Okay. Then we give the schedule. In first week, you have to complete video 1 to video 2. Here you have to complete 1 to 3. Here you have to complete 1 to 4. Like that, we give the schedule. Those corresponding videos are present. I said U1, U2, U3. Then you have the presentations, the course presentation, language presentation, project presentation, and important things. Then here you have the assignments, all the courses, and notes and labs will be there. Notes and lab sessions will be there. This is how the course structure. We are going to give you the hard copy of the important material also, presentation and assignments. Hard copy also will be provided. So, like this, for every course you attend, there will be corresponding topics will be there for you. Okay. Every topic, digital design, system log, everything you take. And I would probably show you one of the course topics also, assignments. If I go to, let's say, I'll take very long. I go to assignments. Any random assignments I take with a common function. It won't be like one page, one line assignments. There will be detailed assignments for each and every one. Okay. This is where the trainer will be supporting you. It's like a class is happening, he will give you 10 minutes time. Complete this question. You're stuck somewhere. The trainer will help you do the question. Next, he will move to the second question. Again, trainer will tell you, take another 15 minutes, do it. Then trainer will support. That's how it works. The point is, we strongly discourage the point of trainer coding and you see the code, and then what it will become typewriting job. You will not learn the coding, you will learn how to do the typewriting. So we strongly discourage that part. We encourage a scenario where you do the things, where you are stuck, trainer comes and supports. Assignments are a very important part of the learning. You see, the Verilog itself has almost 22 assignments for a period of 7 weeks. That means every week you have to complete at least 2 to 3 assignments, 3 assignments. Even if we ignore last 3 assignments, because these 2 you can ignore, they are kind of not covered currently. But even if you think of 20 assignments in a 7 weeks duration, you have to be very focused during. Okay. Yeah. So each and every topic is very well covered because we have spent a considerable amount of time to create presentation on each and every topic. Let's say here with the diagrams, everything embedded, we have created a course. Idea is that if a person has interest to learn and want to benefit out of the course, there is of course. If someone wants to just come, sit, relax, and go, also for them also this course suits. Just that you won't get a job at the end of the day. For both of them, it suits. Okay, for both of them, get their level of support only. One who wants to really benefit, there will be a trainer available to support. Okay, most of the times, the institute will not come and ask you why you do you need support and all that. Every day I cannot ask, right? It's the student has to be proactive in that getting. Next. Next question is, when is the batch classes will be starting? So the batch is going to start from Wednesday. Today is what? 10th December, right? 11, 12, 13. Sunday, 3 days break, and 14th, right? 14th December it will start. Why this 3-4 days delay is because tomorrow we are going to start the backend training demo session. That is Sunday, right? Then 2 days, Monday and Tuesday will be for enrollment purpose. Some students have already enrolled, some will be enrolling. The reason is if someone misses 2-3 days of training, they can't catch up. Because one session goes for around 3.5 to 4 hours. If you miss the topics, next topic you don't know what is happening because you miss that. So hence we start with little delay, but once we start with Wednesday, there won't be any break unless students ask majorly for the important festivals. Let's say Shankranti will be there, Pongal, right? There we do take 1 day off. Even for Republic Day, there won't be any break. That kind of thing, there won't be any break. Major festivals is where people go home. They want that 1 day break. We go for break. Other than that, in a week, 1 day break, common break will be there. Sunday will be there. Can you give 100% placements and what are the companies you give me performance? I give you 100% placements. Simple line. You give me performance, I'll give you 100% placement. That has been the case. I mean, if someone attends and doesn't learn much, then nobody can give any placement. We do have near 100% placements in function verification. When I said some people do call us and desperately ask for the resumes, that's the scenario current. Market don't have a lot of good people available. So wherever there are right set of people, companies want to hire them. Where we have been differentiating is our course is not placement only oriented course. Course is not placement only oriented course. Rather, we focus that students should become independent. Learning, I mean, you should reach a point where you understand the things given a new document, because as I told you in the beginning of the session, here you are going to learn Ethernet MAC. Probably your next 10 years, you may not even do Ethernet MAC anytime. You will probably never do it. But what Ethernet MAC tells you is how to read the document, how to read the specification, how to understand the architecture, how to understand the registers, how to come up with the test bench, test plan, how to develop test bench components, how to develop test cases, everything. That knowledge you apply to other projects. That is what I mean by becoming independent. Primary focus is that. What is that I want to finally hear from a student is that student should say, I'm confident now that I can do the things myself. This is the word we want to listen from the student. Not that he got a placement. We want to listen from a student that I am confident. Now I got the confidence that I can do the things. That is, you won't have, a fresher won't have this confidence. If I give him a document, learn, go read the document and tell me what is there, he won't have that much confidence. The idea is to prepare you. So once you are this happens automatically. Once you are good, see, companies will hire you, right? That's the main focus remains that you should become confident with what you have learned. And it is, as I told you again, it's not going to be one-sided effort where I just teach, you don't do anything, nothing happens. After 1 month, you forget everything. It's almost 70% of effort from your side. 30% is just giving you the directions and clarifying you, giving at every stage, teaching the subject. And what is that 70% effort from your side? Completing the assignment, redoing the assignments, making a notes, preparing little bits. There's a lot of things you are learning. And trust me, every topic you are going to learn, you learn a lot more than what you learn in your BTech. Let's say digital, you learn something. Here, same digital, you learn almost three times more than that. Let's say you have done Verilog during your BTech, you will do 3 times more than what you did in your BTech. Because there, Verilog was only for curriculum purpose. Here, Verilog is for getting job. Now, getting job won't happen just by knowing the basics. It happens only when you are very good with the. So our primary focus remains this only. That is where I really don't even bother about the duration also. Because for me, extending duration is a problem for me. If I extend a course for 8 months, for me, additional cost, right? Somewhere the duration adds to my cost. But my focus remains, let me train 100 people. Let 100 people be good. Rather than just getting some placement. We, of course, now coming back to what all companies you have, we work with almost every services company. What all services companies you can think of? Wipro, Tech Mahindra, UST Global, Cirium, right? Tech Mahindra is Cirium, of course. Then we work with Capgemini. These are the top tier one, right? Mirafra Technologies. And then we have got other companies like Excel Max, Excel VLSI. There are almost, I would say, 60 to 70 companies in the services sector. I'm not able to tell you now. We are all connected with those 70 plus companies. Other than that, then we also connected with product companies like Cadence, Synopsys hire from us. Then we had companies like Onsemi hiring from us. We had Mentor Graphics hiring from us, but they don't hire in bulk. They hire 2 people, 3 people. Okay. So we are connected with almost, I think, 10 plus product companies. But on a services sector, almost every services hires us. That's about it. Next. How frequently a new batch starts? How frequently new batch starts? Generally, it will be 6 weeks, once every 6 weeks. During June to September timeframe, every 5 weeks. Because that is when people pass out of the college, more people will be looking. So to keep the batch strength around 25, what we try to do is we try to keep the batch strength 25, so that what is the advantage of having 25? Around 25 means it works for us to run a batch, and then we can give individual focus to each student. At least if you ask me who are all there, I can tell the names. let's say a place where 100 people are there in a batch. There are places where 100 people batches run even now, right? Functional education. Will it be possible to give focus to each student? It will be difficult. So to maintain that, we run once every 6 weeks or 5 weeks. If we choose both weekend and weekdays, the fees are same for both is not possible. You won't be able to do that. Okay, you won't be able to do that because you need some free time. And doesn't make sense also. Does it make sense attending both weekdays and weekends where the same topic is getting covered in both the times? No, right? So hence we don't give that option. If at all you want to do, we will charge some additional cost and you can. Idea is for what? To discourage people. You choose what you want to be. Do you want weekdays? Do you want weekend? If I do not attend weekend live class, will I get yes? If you miss weekend live class also, you will get the recorded video. Because every video is recorded for me, there is no big major cost of sharing the video. It's just the streaming charges, right? To stream, there will be a cost. Except for that, there is no other additional cost. Okay. In assignment, any doubt means trainer will support. Yes, that is why every day lab session is there. Every day support session is there. Let's say if you have a doubt today, tomorrow there is a live session again. You can always connect with the trainer. If it is weekend students, there is a individual WhatsApp group is there where you can post your queries and we will assign the trainer is added in the group. The trainer will support you. As I told you before, right? For me, the support time is same. You have one doubt today to clarify doubt, it's half an hour. After 1 week also, it's a 1 hour. But if I provide the support today, you will be happy. You will feel good about the institute. If I provide after 1 week, you will not be happy. So we go by that policy. I mean, earlier you support, better it is. That's the policy we follow. For e-learning people, how will we get in the hard copy? We'll send it to our post. Maybe cost has to be borne by the student, but we'll send the hard copy of the material. For e-learning people, how the labs work? Labs are done during the weekends. Weekend sessions are mostly meant for lab sessions, and you can also request for few dedicated one-to-one lab sessions during the weekdays also. Let's say you have a time Monday evening, you want to request for 1 hour session, you post in your group, like you go to WhatsApp group where created for dedicatedly for you, this group I was talking about. You say that I need a 1 hour support session for this specific topic. So there the trainer will tell you that at this time we are going to. Mostly our institute runs on the word of mouth referral. I mean, where 70% of people who join into the course happens through people who have already completed. They referring the people. That's how most it happens. Of course, we are trying to do more of marketing so that we get other enrollments also. The whole point is we focus to make sure that each student should get a good support. He should feel good about the institute. At the end, after 10 years, if I ask you one place where you had a good experience, it should be one place, should be VLSI should be one place where you had a good learning experience. And that's what matters. After 10 years, if you ask me what really matters for me, or what you feel about me, or how much money I made out of this whole process, probably that feeling of you feeling good about me is what is more important for me, right? For e-learning, can we interact with trainer? Yes, I told you, right? Trainer is added into the group with whom you can connect and get your doubts clarified. Will you provide next batch in January? Yes, around 20 January should be there, whichever is a Saturday after Pongal festival, right? Sankranti festival. The next Saturday will be the batch. I think we are done. We will wind up in another 10-15 minutes. I think we are done with all the questions. Any other questions you have? Okay. So just in a concluding note, I wanted to give you a very brief about functional verification. I was telling you about functional verification, right? The process of catching the bugs in the RTL code. Just I didn't go deep into it because it would rather confuse you if I try to teach too many things, SV, UVM, test bench, BFF generator, too many things if I teach you where you don't have much of basics, right? It will confuse you. I want to tell you that the course we offer is one of the in-depth courses. Many times it even fits into a experienced people's requirements also. People who are working at 2 to 3 years experience level, they do enroll and they do learn a lot of things out of that course itself. And another thing you will see about our institute is we offer a wide range of courses. So the courses like the courses on UVM, these are the common courses which everyone offers. Like the courses like RTL design integration, coverage and assertion topics, UVM RAL modeling, then AXI protocol courses, the universal memory controller, USB core verification, DMA controller, bridge verification, FPGA verification, VHDL training, then SOC design and verification. Other than that, gate level simulation, ARM architecture, power aware verification, PCI protocol, DDR protocol. Most of these courses I'm talking about, around 20 courses I said. To my knowledge, except for one, I'm telling just because I don't want to say no one, except for one or two, no one else offers these courses. That is our strength. But having said that, functional verification, Verilog, system Verilog is the biggest strength. I mean, I can teach in a way where probably very few people can teach those subjects. Okay. With that, I conclude the session. Any questions before we end the session? Okay. So in summary, if you are willingness to learn and if you are willingness to put effort, this is the best place for you to learn the functional. Thank you.